Hello students, this is a unit review for Unit 0 in the first, or I guess the 0th unit of calculus. I'm going to take a look at some of the questions that's on the reference sheet and try to walk you through it. First, I want to talk about the unit circle, and I know that we've talked about the unit circle several times in class. I wanted to give you a couple of hints and tricks in order to help you with the unit circle. So you can see on this unit circle, not all of the angles are actually marked. We're missing the angles in the middle, but I wanted to just work on these angles for a second, the ones that correspond to 30 degrees, 60 degrees, 90 degrees, etc. If I start from here, from the 0, I can write a 0 there for that. And I know that the rotation halfway around the circle is going to represent a rotation of pi radians. So similarly, I'll also know that if I rotate all the way around, it's going to be 2 pi radians. If I go from 0 to pi, and halfway between there is going to be the 90-degree mark, otherwise known as pi, divided by 2, because we've gone halfway between 0 and pi. And also between pi and 2 pi, between 1 and 2 pi, you can call it 1.5 pi or 3 pi over 2. Hopefully that was helpful. I know also that the other demarcations here, the other points here, are situated around the circle in twelfths. So this is 1/12 around the circle, this is 2/12, 3/12, 4, 5, 6, etc. So if all of them are twelfths around the circle, that means this represents a sixth. So we would call this pi divided by 6. This one over here is 2 pi over 6. We can simplify that to pi over 3. This we already named as pi over 2, which corresponds to 3 pi over 6. This one is 4 pi over 6, but instead of writing it as 4 pi over 6, we could easily simplify that to 2 pi over 3. This one is 5 pi over 6, which we cannot simplify. 5 pi over 6. This is 6 pi over 6, which is the same as pi. 7 pi over 6, which cannot be simplified. 8 pi over 6, which is the same as 4 pi over 3. This one is 9 pi over 6, aka 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And this one is 11 pi over 6, which cannot be simplified either. And 12 pi over 6 corresponds to 2 pi. So hopefully that was helpful. I also want to talk about the so-called halfway points between, for example, 0 and pi over 2. That's this angle that has not been marked as of yet. That angle we know is pi over 4. Sorry, I'm writing a little sloppy here. This angle over here represents another halfway point between pi over 2 and pi. Well, we know that the halfway point between 1/2 of pi and 1/2 of pi is 3/4 of pi. So I'll mark that, and I'll mark that as 3 pi over 4. Here is another halfway point between the straight sections. We know that this is pi and this is 3 pi over 2. The halfway point there is going to be 5 pi over 4. And this halfway point in between 3 pi over 2 and 2 pi is going to be 7 pi over 4. So those are all the important angles that you need to remember, and the coordinates all come from the information that we learned about in class. For example, pi over 6, you need to remember that the coordinates for pi over 6 are radical 3 over 2 and also 1/2. You should remember that for pi over 4, the coordinates are radical 2 over 2 and radical 2 over 2. For pi over 3, the coordinates are 1/2 and radical 3/2. And then the coordinates for 0/2 pi are just 1, 0. And the coordinates for pi over 2 are 0, 1. All the rest of the coordinates can be based on these coordinates. For example, on this side of the unit circle for pi over 6, we have radical 3 over 2, 1/2. On this side of the unit circle, the x value is negative, so it's going to be negative radical 3 over 2. but the y value is the same, so we call it 1/2. On this side of the unit circle, both of the x and y values are positive, but on this side of the unit circle, the x and y values become negative. So this we could call a negative radical 2 over 2 and negative radical 2 over 2. I'm not going to fill out all the coordinates, but I wanted to walk you through the concept of filling out the unit circle in that way. All right, take a look down here at the logarithmic equations. I want you to pause the video now, try these logarithmic equations, and in a few moments I'm going to show you the correct answers, and I'll walk you through it verbally. All right, take a look at the first problem. It was 14e to the 6 minus x plus e to the 12x minus 7 equals 0. What we did first was we brought the e to the 12x minus 7 onto the other side so that we had two expressions that both had e in them. We know that e is the opposite of natural log, so we took the natural log of both sides. Once we did that, we saw that this wasn't just an e expression, it had a 14 in front of it, so what we did was we separated natural log of this into natural log of 14 plus natural log of e6 minus x. And we did the same thing on the other side. Notice that this e to the 12x minus 7 became negative 1 times e to the 12x minus 7. Then what we did was we translated ln of e to the 6 minus x into simply 6 minus x, because the ln and the e are opposite operations or inverse functions. They eliminate each other. Same thing here, the 12x minus 7 and the negative 1 stays the same. Then what we did was we moved all of the values onto the left side, and then we moved all of the variables to the right hand side, and then we divided both sides by not 3, but 13. That should have gotten you your correct answer. Incidentally, this is the procedure to go about solving this problem. One thing you should notice is that during the course of the problem we get natural log of negative 1, and you should remember that natural log of negative 1 is an undefined quantity. It gives you a non-real answer. So procedurally, this is how you would go through it. However, the natural log of negative 1 is not something that you can find. For this next problem, I wanted to isolate the natural log of 2x minus 1 over 7. So the first thing I did was I identified that the natural log of 2x minus 1 over 7 is equal to natural log of 2x minus 1 minus the natural log of 7. That's one of the log rules. Then we moved the 1 to the other side. We subtracted the 1 from both sides and divided both sides by negative 8. So we got negative 13/8 on this left side. On the right side, we had the two natural logs. Keep in mind that this natural log of 7, is just a value. If you put in the calculator, you'll get a number right away. This is the variable, though, which is the thing we have to solve for. So we took the value and moved it to the other side. And then we put both sides to the e power. We exponentiated both sides. After we exponentiated both sides, the temptation might be there to take e and ln of 7, natural log of 7, and eliminate those. Since the natural log of 7 is within this larger expression in the exponent, you can't do that, unfortunately. But remember, this whole entire expression here on the right-hand side simplifies to one value. Then we got 2x minus 1 on the left-hand side, because as you remember, e and ln, e and natural log cancel each other out or eliminate. And then finally we got, adding 1 to both sides and dividing both sides by 2, we got x value of 1/2 times e to the 13 over 8 negative plus natural log of 7 plus 1. Once again, pause the video, take a look at these two, and I will give you the answers in a moment. All right, in this problem, we noticed that log z was multiplied by 2, so we were able to take that and make it into an exponent, so we turn that into log of z squared. One other thing you should notice is that log of z squared minus log of 7z minus 1 can be easily simplified by turning that into a division problem, which is what we did here. Then once we have log of just one single expression, we can put both sides to, well, not e, but 10. And the reason we were able to use base 10 was because any log that does not have a stated base is considered to be the common log, which means base 10. On the left-hand side, once we do 10 to the power of log z squared minus divided by 7z minus 1, that just eliminates the 10 and the log. On the right-hand side, 10 to the 0 is 1. Then we cross multiplied, or simply multiplied both sides by 7z minus 1, and we got z squared equals 7z minus 1. And then it looks like we can turn it into a pretty straightforward quadratic. Now, this procedure is a procedure that I want you to be able to do. However, I'm not going to be asking you to take a quadratic like this, which can't be factored using A&M method, and solve it. However, if you were to use the quadratic formula on this, you would get these two x values. So again, I'm asking you to be able to solve a logarithmic equation that might give you a quadratic equation as the last part of it. But I do not expect you to be able to, or I do not expect you on this test to be using the quadratic formula. I'm going to be giving you something that's a little bit easier to factor using the AM method. Take a look at the fourth one. I will show you the answers in a moment. Taking a look at this equation here, the first step that I saw was to factor out a t value. We know that the t variable is the variable we're trying to solve for. So we have t times 2 minus e to the 6t minus 1 equals 0. I can take this t and separate it out into just t equals 0. And on the right side, I can take the remainder of it, 2 minus e to the 6t minus 1 equals 0, and write it as a new equation. Now I'm going to solve the right-hand side. I add e to the 6t minus 1 to both sides. I take the natural log of both sides because my base is e. Natural log of 2 is a constant, so I don't have to do anything with that. But ln and e eliminate. Then I'm just going to solve for t by doing some inverse operations. So again, I'm going to get two answers for this. I'm going to get t equals 0, and I'm also going to get 1/6 times ln of 2 plus 1. Remember, that's just going to be a constant term. Take a look at the next side. On this next side, using the unit circle, try to evaluate these trig expressions, pause the video, and come back to it. For the first trig expression, you should have seen that cosine of negative pi over 4 corresponds to the angle 2 pi minus pi over 4, which is 7 pi over 4. And you know that 7 pi over 4, while looking at the unit circle that we made, corresponds to radical 2 over 2 as its x, and negative radical 2 over 2 as its y. In order to figure out which one is x and which one is y, you just remember that cosine is x, and then sine is y. So in this case, we're looking for the x value, where the angle is 7 pi over 4, which is radical 2 over 2. For this next trig function, you should know that negative 23 pi over 3 corresponds to negative 5 pi over 3. For an explanation as to why, think about spinning around the unit circle. I know that negative 23 pi over 3, I've already spun around the unit circle 3 times in the wrong direction, giving me negative 18 pi over 3, or 6 pi. The next 5 units brings me to negative 23 pi over 3. So after I've spun around the unit circle 3 times, I get back to negative 5 pi over 3. Now remember that any negative angle is equal to 2 pi minus that angle, which is equal to pi over 3. Pi over 3 is one of our common angles, which corresponds to 1/2 and radical 3 over 2. And that gives us the sine, which is the y value, is radical 3 over 2. Referring to your unit circle, you should know that sine of 2 pi over 3 is equal to radical 3 over 2. And you might say, well, why am I finding sine? It asks for cosecant. Well, cosecant is the inverse of sine. So if I find the sine of any angle, I can turn it into the cosecant by taking its inverse. I could rationalize this, but I'm not going to require you to do that. It would give you radical 3 times 2 divided by 3. Take a look at the last one here. Once again, when we get to an angle that's bigger than 2 pi, we start subtracting 2 pi from the angle until it makes sense. So what we've done is taken 17 pi over 6, subtracted 2 pi from it, it gives us 5 pi over 6. 5 pi over 6 is one of our common angles, and I know that cosine 5 pi over 6 is equal to radical 3 over 2, that's the x value. So in order to find secant, we simply need to invert it, or take the inverse. I'm going to show the answers for these trig equations. I'm not going to be able to comment because of the length of the video, but I will show you the answers, and you can check your work. Alright, hopefully you're able to check your answers here. For this first equation, you should notice that we converted everything to decimals, so it was easy to compare to the interval. We eliminated these two because they were outside of the interval. For the second equation, we eliminated these two because they were out of this interval. They were past 6.23. For this one, we did a u substitution, which was similar to the one we did in class. We said that this was a quadratic with sine being the x value. Then we solved, and we found that sine of x is equal to 2 on this side, which is not true because sine is maximum of 1. And on this side, it's a square root of a negative, which is imaginary. Good luck studying.